Hi everybody, we're going to get started. Well, good afternoon. My name is Maureen Marcella, and I would like to thank you for joining us for our fourth New England QIN-QIO Healthcare Associated Infection Collaborative webinar on HAI Analytics. Before we get started, I'm going to quickly review a few housekeeping items. First of all, the disclaimer that there is no conflict of interest in regards to the presentation or the presenters. This webinar will be recorded and available within a few business days on our website. I'll provide you with the details on accessing the recording at the end of the webinar. The phone lines will remain on mute for the duration of the presentation. We will take questions at the end, and I will provide you with instructions on how to unmute your line at the end of the presentation. Now, to introduce our speakers. Morphis is the Manager of Analytic Services here at HealthCentric Advisors in Rhode Island and the prime contractor for the New England QIN-QIO. As part of his work, Blake is involved in the Rhode Island's HAI Collaborative, and his knowledge for analyzing NHS data is used to support the work of infection preventionists for hospitals in New England. Blake holds a bachelor's degree in computer information systems from Rhode Island College, where he is also a recognized member of an International Computing Honor Society, upstate by Epsom. He also serves as co-chair for the American Health Quality Association's National Analytic Network. Prior to joining HealthCentric Advisors in 2009, Blake worked as a healthcare analyst for Our Lady of Fatima Hospital, where he spent 10 years supporting analytic and information technology needed of clinical and quality improvement teams. And the newest member of our team is Alyssa Sylvaria. She is a health information analyst and works alongside Blake in the New England QIN-QIO efforts. She has a master's degree from Brown University and graduated from Providence College as a poli-sci major and mathematics minor. She previously worked as an analyst at the Providence Plan as an intern at Lifespan with the Chief Quality Officer during her graduate studies. As part of her work for the Medicare QIO, Alyssa serves as the lead analyst in supporting the Reducing Healthcare Associated Infections in Hospital Tasks. We welcome both Blake and Alyssa. Blake, the line is yours.
Hi everyone, I'm Alyssa. Let me get it started. So the goals for today's presentation are first to review the standardized infection ratio and how to assess a SIR for statistical significance. We'll then look at how NHSN is deriving predicted or expected infections for CLABSI, CAUTI, and C through risk adjustment models. Next, we'll discuss ways to present NHSN data, and we'll review the provider reports that we can produce for hospitals that are participating in the 11th scope of work. After that, we will discuss the new TAP reports option that's available in NHSN, and then to wrap things up, we'll touch on the fiscal year 2017 hospital value-based purchasing and how HAI measures are involved in value-based purchasing. Okay, so the first topic we're going to cover is how to understand and interpret a standardized infection ratio, or SIR. The SIR simply compares the number of observed infections, your actual infections, to the number of infections that you are predicted to have, which is also referred to as expected. To calculate a SIR, then, we just divide the number of observed by the number of predicted. A SIR will only be calculated, though, if the number of predicted infections is greater than or equal to 1. When the predicted number of infections is less than 1, it's considered too low to calculate a precise SIR to be able to actually compare across units or facilities. So if your SIR isn't calculated for this reason, you can try calculating a SIR for a longer time period, such as a year, which would be the summer year option in NHSN. So the SIR is used for a few different reasons. We can use it to look at trends and comparisons over time at a national level. state or facility level, and even down to a specific unit location. The other valuable aspect of the SIR is that it can adjust for patients of varying risk and for unit and facility characteristics, depending on the topic. Because it has these adjustments built in, using the SIR to make comparisons between facilities or units can be more meaningful, as opposed to just comparing incidence rates, for example, which are not adjusted. Now, we'll review some simple examples of how to interpret a SIR. First, you can see that we have 5 observed and 5 predicted, which gives us a SIR of 1.0. Thus, a SIR of 1 just means that the number of observed infections is the same as the number of predicted infections. This can also be interpreted to mean that the SIR was no different than the national baseline. If there are more observed infections than predicted, the SIR will be greater than 1. If the SIR is 1.6, for example, you would say that we had 60% more observed than we expected. If there are fewer observed infections than predicted, the SIR will be less than 1. If the SIR is 0.2, we can say that we had 80% less infections than predicted. So if the SIR equals 1, we just learned that it means that the observed is the same as predicted. However, most of the time the SIR is going to be above or below 1. To determine whether the SIR is actually statistically different from 1, either better or worse, we can use these things called p-values and confidence intervals. So the statistical difference that we're trying to identify is referred to as statistical significance, or just significance. This tells us that a result can be interpreted as meaningful and not just a random luck of the draw. First, we'll start off talking about the p-value. This looks at the probability that two numbers are statistically the same. If a p-value is a very low number, close to 0, we can feel confident that the SIR is statistically different from 1.0, or the national baseline. The cutoff that is usually used to judge whether a p-value is significant is 0.05. And in this example, you can see that the SIR is 0 here, and the p-value is definitely less than 0.05. So we would call this SIR statistically significant. This also makes intuitive sense because 0 actual infections compared to an expected number of almost 31 is a big difference. In the next example, the SIR is 1.566. There were 56.6% more infections than expected. But we want to know whether this location is performing statistically worse than expected. When we look at the SIR p-value, it is definitely above 0.05. So we can say that there is no significant difference between the number of infections observed and the number of infections expected. So the answer would be no. It is not statistically performing worse than expected. So in the second example, there were 0 infections for the quarter, which gives a SIR of 0, which is great. That's the goal. However, our SIR p-value is not lower than 0.05. So again, we would say that there is no significant difference between the number of infections observed and the number of infections expected. This is understandable, though, because 0 infections is not very far away from the 2.25 low that were predicted. So another way of determining the SIR statistical significance is with confidence intervals. And a confidence interval is just a range of numbers around a measurement. in this case, a range around the SIR. The confidence interval contains how reliable or how precise the measurement is. The confidence interval is usually written by showing the maximum and minimum, which we call the upper and lower limits. And the confidence interval also helps us know whether the SIR is statistically significantly different than a SIR of 1. So now that you know what a confidence interval is, let's talk about how to interpret one. It's important to understand that if the SIR confidence interval range includes the value of 1, then it tells us that the SIR is not significant. If it does include 1, it tells us that the number of observed infections is not significantly different from the number expected. In this example, we've got our SIR of 1.566, and we want to know if it's significantly higher than 1. We're going to focus on the 95% confidence interval column to check this statistical significance. Ignore the p-value column, even though you've mastered that part already. And the confidence interval box tells us that the lower limit is 0.427 and the upper limit is 4.008. Because the lower limit is less than 1 and the upper limit is greater than 1 definitely falls within the confidence interval. And so we would say that we cannot conclude that the SIR is different than 1. Now this graph shows the SIR and confidence intervals for one example location over 2 years. The 2013 SIR, the blue bar on the left, is higher than a SIR of 1. So the black bar shows that the confidence interval crosses over 1, where the red line is. So we can conclude that the SIR is not significantly different from 1. The SIR for 2014, though, is below 1, and the confidence interval is also fully below 1. So we can say with confidence that the 2014 SIR was significantly lower than the national baseline. Okay. And now that you know how to determine the significance of your SIR, we're going to have a polling question. So when the poll is open, you'll have 30 seconds to answer the question, which will display on the right side of your screen. And we want to know, is the SIR different than expected? You do need to exit full screen if you're in that mode in order to answer the poll. So is the SIR different than expected? Your options are, yes, it's better than expected, yes, it's worse than expected, or no, it's not significant. And just a reminder to hit submit. You can't just select it, you also have to hit submit at the bottom. Alright, so I think the poll is over and we're just waiting for the results to show up. This is my first time doing this, so let's see. Okay, so let's see. I do see that we got 38 out of 106 said B, and the correct answer is B, yes, it's worse than expected. So that's great. We can definitely see, we can see that the confidence interval is well above 1, and the p-value is also well below 0.05. Alright, and now that we've talked a lot about statistical significance, we're going to shift the focus a little bit and look at how NHSN calculates the number of predicted or expected infections and events, which is critical for calculating the SIR. So we'll start with an overview of the predicted number. CLABSI and CAUTI are similar in the way that NHSN calculates the predicted infections, but CDIF is a bit different. For CLABSI and CAUTI, NHSN calculates the predicted number of events using national baseline infection rates. These baseline rates are specific to each unit type. Some units are further stratified by whether they are teaching facilities and by the bed size. However, for CDIF NAVID events, NHSN uses a regression model to predict the number of events for your facility. So as you can see in the formulas, the predicted infections for CLABSI and CAUTI are calculated similarly. You take the number of days, multiply it by the national baseline rate for that unit type, and divide by 1,000. The key difference is the baseline time period. CLABSI uses data aggregated from 2006 to 2008, and CAUTI uses data from 2009. The national pooled mean for each unit type is used by NHSN for the baseline, which is just the national rate for 1,000 device days. And here we have an example to demonstrate. For CLABSI, this baseline rate for a med-surg ICU with less than 15 beds is 1.5 CLABSI per 1,000 central line days. So to get the expected number of CLABSI per 1,000 central line days, we would just multiply the number of central line days that the unit had by 1.5, our baseline rate, and then divide by 1,000. So make sure you have a good sense of this formula here. We're going to have a polling question on the next page. Take it. Now let's take a look at a CAUTI example. The national baseline CAUTI rate for a non-teaching med-surg critical care unit is 1.3 infections per 1,000 urinary catheter days. For this example, we have a non-teaching critical care unit with 3 infections and 1,500 catheter days. We need to know the total number of infected infections, and we need to calculate the SIR. So let's refer to the table on the side. We're missing the number of expected infections, so we need to calculate it. To figure out the number of expected infections, we need to multiply 2 numbers and divide by 1,000. But which 2 numbers do we need? So I'd like to poll the audience to answer this question, and you can see the answer choices on the screen. Is it 3 times 1.3, 1,500 times 1.3, or 1,500 times 3? Hopefully everyone got a chance to answer, and I'm just waiting for the results to show up. Okay, and looking pretty good yet, other than the 61 out of 111 with no answer. So the answer was 41 out of 111, got the right answer, 1,500 times 1.3, so C is correct. We just multiply the number of catheter days times the national baseline. Alright, so if we do the math out, 1,500 times 1.3 divided by 1,000 gives us 1.95 expected infections. And the next step is to calculate the SIR. There will be a poll for this, but I'll give you a moment to think about how we would calculate the SIR. which two numbers would we need? So the answer would be to take the 3 observed infections over the expected infection, so 3 over 1.95, which gives us a star of 1.54. Now I'll go over how NHSN calculates predicted events for CDIF, Rapid Healthcare Facility Onset events. The main thing that you need to know is that NHSN calculates predicted events with a risk adjustment model that uses regression. This table shows the regression model, but do not get overwhelmed if you don't understand everything that's going on. We're going to break it down and simplify everything. So first, we're just going to focus on the things listed on the left side of the table and block out everything else. When you look at the table now, you can see that there are just 4 key variables that play a role in predicting events. These are, first, the CDI test type, next, community onset CDIF admission prevalence rate, then facility bed size, and finally, medical school affiliation. Now let's break down each of these variables to see how they relate to the predicted number. First is CDI test type. NHSN adjusts for this because the more sensitive the test is, the more predicted events there are likely to be. An NAAT test is at the top, meaning you will have more predicted events if you're using this test type versus another test type. Next is EIA. And this type of test would also increase the number of predicted events, but not by as much as the NAAT test would. If you're not using either of these 2 test types, then it will not raise your number of predicted events. Next is your facility's community admission prevalence rate. This is included because the higher the community onset CDIF admission prevalence is, the higher your number of events would be. And next we have facility bed size. Having more than 245 beds will increase the number of predicted events the most, followed by having 10 to 245 beds. Having 100 or fewer beds will not increase the number of predicted events. And the last variable is medical school affiliation. Being a major teaching hospital will increase the number of predicted events the most, and then graduate teaching will also raise your predicted events, but not by as much. And non-teaching status will not affect the predicted events. And let's now take a look at how changing these variables actually changes the number of predicted events. And we'll look at a demo facility's 2013 quarter 1 data to do this. And as you can see, this facility is predicted to have about almost 36 events, 35.495. This facility is a major teaching hospital that uses an NAAT test type and has more than 245 beds. This is filled in the table in the column titled Original Demo Facility Example. And at the bottom you can see that these facility characteristics led to that 35.495 predicted events. But now let's try removing teaching status to see how this would affect the facility's predicted events. So if we change the teaching status from major teaching to non-teaching, you can see that the number of predicted events drops to about 29. If we try changing the bed size in addition to teaching status, and the bed size was reduced to between 100 and 245 beds, the total number of predicted events drops to about 26. So without getting too technical, this example hopefully showed you that the different factors included in the NHSN risk adjustment model can really change the number of predicted infections for your facility. And just to recap, the key variables that those were are test type, community onset, CDIF prevalence, bed size, and teaching status. And now I'm going to hand it over to Blake, who's going to talk a little bit about your HAI data.
Thank you, Alyssa. So we'd now like to shift the focus of this presentation to show you how we are looking at HAI data for our providers participating in the 11th Statement of Work. We'd now like to ask you, what's your data story? What does your data tell you, and how are you tracking HAI results? I would encourage you to look into your own data, export it from NHSN, and enjoy. While examining p-values and confidence intervals can be very useful, we should also keep in mind that a result that is not statistically significant does not mean that it does not have meaning. Be sure to recognize your success and acknowledge your failures. A SIR of 0 is a great accomplishment, no matter what the p-value is. While the tables that are provided within NHSN are very useful, and NHSN does have charting functionality, I encourage you to look into exporting your data and digging deeper. I'd now like to show you the reports we have developed for our facilities participating in the 11th Statement of Work. For the 11th Statement of Work, we will be providing reports on CLABSI, CAUTI, and C. These reports will be available to facilities participating in the 11th Statement of Work, but will be limited to the topics and locations that a facility agreed to work on for the 11th Statement of Work. We'll first talk about the CLABSI and CAUTI reports. However, since both of these reports are based on device-associated infections, for today, we will cover just CAUTI, since the CLABSI report is virtually the same as the CAUTI report. Both the CLABSI and CAUTI reports are based on a specific location at your facility. This is just to give you an idea of what the entire CAUTI report looks like. It's composed of 4 sections on 2 pages, and I'll walk you through each section of the report. The CAUTI report starts off looking at a particular location's CAUTI incidence rate per 1,000 urinary catheter days. For this section of the report, 2 one-year time periods are compared to one another. The table to the left will provide you with the data that's needed to calculate a CAUTI incidence rate. To calculate the incidence rate, you simply divide the observed infections by the number of urinary catheter days and multiply by 1,000. For example, the 0.99 incidence rate for 2014 is 1 observed infection divided by 1,007 multiplied by 1,000. Below the table is a relative improvement rate. This rate measures the percent change in incidence rate. For this example, 57% is the percent change between 2.31 and 0.99. A positive percentage is used to indicate a decrease in incidence. Therefore, we can say that this location has decreased CAUTI incidence by 57%. The chart on the right provides a visual depiction of the data. The blue columns display the 2 CAUTI incidence rates versus one another, and the red line, marked with 2.40, is the NHSN CAUTI incidence mean for this particular location. On the second half of the first page of the CAUTI report, we provide you with a SIR comparison. Just like the CAUTI incidence, this section will examine 2 one-year time periods. The table to the left provides the data needed to calculate the SIR, and it also provides the confidence interval as well. Just below the 95% confidence interval is an interpretation on whether or not this location's confidence interval is statistically significant. If the result for significance is no, then the statistical result versus national baseline will state no different. On the other hand, if the result is statistically significant, it will indicate whether or not the result versus national baseline is better than or worse than the national baseline experience. The chart to the right provides a visual depiction of the SIRs for the 2 time periods represented by the blue columns. The red line provides a reference to a SIR of 1.0, as we know that a SIR that is above 1 indicates more infections than expected, and less than 1 indicates less infections than expected. The last thing to point out on the chart are the 95% confidence intervals. We know that if the lower confidence interval is above 1, then the result is statistically worse than the national baseline experience. And if the upper confidence interval is below 1, then the result is statistically better than the national baseline experience. For this example, we can see that the confidence interval spans across 1, a red line, and therefore the result is no different than the national baseline experience. On page 2 of our CAUTI report, a CAUTI incidence rate quarterly trend is provided for the past 8 quarters. Again, the NHSN CAUTI incidence mean for the particular location is provided as a reference with a red line. Below each quarter's label on the horizontal axis, it says INF, which provides you with the number of observed infections that were seen during that quarter. For example, in quarter 4, 2013, they had 2 observed infections during that particular quarter. The last section of the CAUTI report is the urinary catheter device utilization ratio. The urinary catheter device utilization ratio is a comparison of the total catheter days versus the total number of patient days. A ratio of 1 would indicate a high utilization of urinary catheters, since that would mean a location had just as many urinary catheter days as it did to patient days. For example, if you have 1,000 urinary catheter days and 1,000 patient days, then you would have a device utilization ratio of 1. A ratio of 0, on the other hand, would indicate that there was no use of urinary catheters. On the chart, the location's urinary catheter device utilization ratio is provided for the past 8 quarters. For reference, the NHSN device utilization mean is provided, which marks what was seen as the average utilization of urinary catheters for the given type of location. In this example, the device utilization mean is 0.68, meaning that for this type of location, the average national utilization of urinary catheters is 68% of the total patient days. On the chart itself, if a given quarter's utilization ratio is above the NHSN mean, then the column is shaded red. And if the utilization ratio is below the mean, then it's shaded in green. And I'd like to take a few minutes to talk to you about our C. difficile report. This is our C. diff lab ID events report. The first page of the C. diff report is designed to be exactly the same format as the CLABSI and CAUTI reports. Let's take a look at some of the differences. Since we are looking at laboratory identified events, also referred to as lab ID, we refer to this as C. diff lab ID events incidence rate for 10,000 patient days. We can see that on the table to the left, we have data on observed events, patient days, and an incidence rate. In this example, we can see in 2014, this facility had an incidence of 6.97, meaning that for every 10,000 patient days, this facility saw approximately 7 lab ID events. One last thing to point out is that this is only looking at events that are identified by NHSN as healthcare facility onset events. This is the standardized infection ratio for C. diff lab ID events. The curve for C. diff lab ID events compares your facility's healthcare facility onset events to the number of expected events. I will not cover the confidence interval for this example, as it works exactly the same as it does for CAUTI and CLABSI. However, I do want to point out that this example displays statistically worse and statistically better confidence intervals. If you take a look at the chart on the right, for 2013, we can see that the entire confidence interval is above 1. When this happens, we know that the result is statistically worse than the national baseline experience. In 2014, we can see the opposite. The entire confidence interval is below 1, and is therefore statistically better than the national baseline experience. On page 2 of the report, we provide your facility's 8-quarter trend of the SIR. Since we have more data to work with on C. diff, most hospitals will have enough patient days to calculate at least one expected infection Therefore, for CDIF, we decided to twin the SIR. The confidence intervals are again provided so that you can see the result is statistically significant. The last part of the CDIF report is a monthly trend of your facility's healthcare facility onset events versus admission prevalence. Admission prevalence is simply community onset, or CO, events, plus community onset healthcare facility associated, or COHCFA events. You can examine this data to spot any trends or outliers that may have occurred over the past 2 years at a monthly level. I like to think of our reports as an appetizer. Exploring these data should whet your appetite and leave you ready to jump into your own data story. Our reports can highlight opportunities for improvement and can highlight your areas of success. And we are always here to help. Remember to add a healthy dose of HAI data to your diet. In moderation, it can have many benefits. We would now like to spend a few minutes with you to discuss the new CAP reports that are available for your facility within NHSN. Before we get started on discussing the CAP report, you can find your facility's CAP report under the Output Options section in NHSN. Underneath the CMS reports is a folder is a new CAP reports folder. Expanding the CAP reports folder will reveal the CAP reports available depending on the type of facility you're at. This is what a CAP report looks like. The example we see here is a CAP report for CAUTI, and the report breaks down your facility by location and ranks locations within your facility based on a concept called Cumulative Attributable Difference, or CAD for short. By default, the report is sorted by CAD so that locations with the highest CAD are at the top of your report. Let's take a closer look at just what CAD is. So what is a CAD? The cumulative attributable difference will provide you with how many excess infections you need to eliminate in order to meet a target SIR. For example, let's say your facility has a CAUTI SIR of 1.25, and let's say your target is to achieve a SIR of 0.75. The CAD will tell you how many infections you have to eliminate in order to achieve the 0.75 target SIR. Let's break down the example provided by our CAP report. This facility's ICU had 5 CAUTI events, 400 urinary catheter days, a device utilization percentage of 32%, and a CAD of 4.31. Just note, by default, NHSN is using the target SIRs that were set in the HHS action plan. For CLABSI, the target is 0.50, CAUTI 0.75, and for CDIF 0.70. NHSN has stated that they plan to add functionality to let you define your target SIR. In the meantime, you need to be aware that these are the default SIRs being used for your CAP reports. Let's discuss just how CAD is calculated. Then we'll look at how NHSN derived a CAD of 4.31 in our example. As we just reviewed, currently NHSN uses default target SIRs, and for CAUTI, the target is 0.75. CAD is simply the observed infections or events minus the predicted times the SIR target. This is using the same data you've always looked at. The observed and predicted are no different than what you are using currently to calculate your SIR. Since 0.75 is the target SIR for CAUTI, the CAD formula for CAUTI is observed minus the predicted, which was multiplied by 0.75. Let's now look at how NHSN calculates the 4.31 CAD in our example. Let's plug in the numbers. First, we had 5 observed events, so the CAD is equal to 5 minus the predicted multiplied by 0.75. Predicted isn't provided on the CAP report, but I can tell you that it's 0.92. So our formula is now 5 minus 0.92 which is multiplied by 0.75. The next step is to multiply the predicted by the target SIR. That is 0.92 times 0.75, which comes out to 0.69. The last step is subtract 0.69 from 5, which results in the 4.31 CAD. So let's talk about interpreting the CAD again. The 4.31 CAD means that in order for this location to have a SIR of 0.75, it would have to eliminate 4.31 infections. Let's just take a look at why that number is correct. While we're not supposed to calculate a SIR without at least one predicted infection, let's break the rules. If this location reduced observed infections by 4.31, the result would be 0.69 observed infections. Dividing 0.69 by the predicted 0.92 would result in our target SIR of 0.75. While we know that numbers between 0 and 1 are not possible, the example is to show you how achieving the CAD would result in reaching the target SIR. Let's recap the TAP report. The good news is that NHSN calculates everything for you. Again, you can see that the report is ranked by the CAD. This means at the top of the list you will see the locations with the highest CAD or excess infections. You most likely will also see negative CADs, which would indicate that there were less observed infections than predicted. Also, on the last column to the right, the pathogens involved in the events are summarized. You can refer to the TAP report footnotes for a listing of the pathogen abbreviations. TAP reports are a very convenient way for you to monitor your entire facility in one report and help you target which locations are in most need for improvement. Now I'd like to talk to you about the HAI measures and their role in hospital value-based purchasing. For fiscal year 2017 hospital value-based purchasing, we are currently 5 months into the performance period. The performance period is the time period used in value-based purchasing to evaluate your hospital's performance on the various measures involved in value-based purchasing. Let's take a few minutes to discuss the scoring methodologies involved in value-based purchasing. Now, this is a very high-level overview, and I'll explain all of these concepts in more detail as it relates to the HAI measures. First, all measures have a baseline time period, a threshold, which is the 50th percentile nationwide at baseline, and a benchmark, which is the mean of the top decile nationwide at baseline. All measures are scored on a scale of 0 to 10, and finally, all measures are scored in two ways, achievement and improvement. These are the SIR thresholds and benchmarks for all of the HAI measures that are involved in the fiscal year 2017 hospital value-based purchasing. This means that in order for your facility to receive points on achievement, the 2015 SIR for any of the measures displayed must be at or below what is displayed here in the threshold column. As you can see here, the benchmark for all measures is a SIR of 0. Let's first take a look at how achievement scoring works. CMS defines the threshold as the 50th percentile at baseline. That means for the HAI measures, the threshold is the value of the SIR that ranked in the 50th percentile at baseline. The benchmark is defined as the mean of the top decile nationwide during baseline. However, as we saw on the previous slide, the top decile for all HAI measures is a SIR of 0. That means for HAI measures in value-based purchasing, in order to get the maximum points, you must have a SIR of 0. Your facility is eligible for achievement scoring when a measure exceeds the threshold. Of course, since a lower SIR is better, exceeding the threshold would mean being below the threshold SIR. The closer your SIR is to the benchmark, the more points you will receive. And if you have a measure that meets the benchmark, your facility will receive a maximum of 10 points for that measure. Let's take a look at an example. For fiscal year 17, the CLABSI threshold is 0.457 and the benchmark is 0. This means that if your facility SIR is at or below 0.457 on CLABSI, then it will be eligible to receive achievement points. We just reviewed achievement scoring. Let's now review the other scoring method, which is improvement. For each measure, we have a baseline time period and a performance time period. For fiscal year 2017, the baseline time period is 2013, and the performance time period is 2015. Each measure is evaluated in terms of how much improvement your facility has made from baseline to the national benchmark. As a reminder, all measures are scored on a scale of 0 to 10 for improvement. The maximum number of points you can receive is 9. This is due to the fact that reaching the benchmark is scored as 10 points under achievement. Let's take a look at another example. Let's say we have a hospital that had a baseline 2013 CLABSI SIR of 0.925 and their 2015 CLABSI SIR came in at 0.50. That would make this facility eligible for improvement scoring. It is important to know that the thresholds we looked at under achievement scoring are not relevant to improvement scoring. Improvement scoring is solely focused on how much improvement has been made from baseline to benchmark. Just to recap the two scoring methods. In value-based purchasing, you can be scored on achievement, meaning that your score is compared to the threshold of the benchmark. The measure is also scored by examining how much improvement has been made from baseline to the benchmark. All measures are scored using both methods, and the higher score of the two is used. Let's now take a closer look at how these scoring methods work. We're first going to break down achievement scoring and examine just how this works. So when we look at achievement scoring, we know that between the threshold and the benchmark is a range. For example, the fiscal year 2017 CAUTI threshold is 0.845 and the benchmark is 0. Since the benchmark is 0, we know that the range from the benchmark to the threshold is simply 0.845. On the scale displayed on this slide, the blue triangle represents the threshold of 0.845 and the blue square represents the benchmark of 0. Below it, we can see the range of 0.845. Next step is to divide this range by 9, not 10, and plot it equally on our scale from the threshold to the benchmark. You can see approximately what this plotting would look like on the scale displayed. Notice how for each incremental point from the threshold, you pick up more points as the SIR gets closer to the benchmark. Let's examine a few achievement scores. A SIR of 0.68 would receive 2 achievement points. A SIR of 0.42 would receive 5 achievement points. And of course, a SIR of 0 would get 10 achievement points. Improvement scoring works nearly the same as achievement, but there are a few differences that I'd like to cover as we go along. The first being that instead of using the threshold, you will use your baseline SIR. That means we are now looking at the range that is between the baseline SIR and the benchmark. For example, for 2017, a facility that has a baseline 2013 CAUTI SIR of 1.15, and we know the benchmark is 0. You can see on the scale, the blue triangle represents the baseline SIR of 1.15, and the blue square is the benchmark of 0. In between these two data points is a range of 1.15. This time, we will divide the range by 10, which comes out to 0.115. If we plotted our 0.115 on a scale, it would be approximately what we see on the scale displayed. The most important thing to note is that the scale for improvement is 0 to 9. Therefore, a very slight improvement in their SIR may result in 0 improvement. The other thing to point out is that reaching the benchmark would result in 10 points under achievement, not improvement. Using our scale, let's take a look at a few examples. A SIR of 1 would receive 1 improvement point. A SIR of 0.56 would receive 5 improvement points, and a SIR of 0 would receive 9 improvement points, but would also receive 10 achievement points. One quick note about SSI. While SSI, colon, and hysterectomy have their own individual thresholds, the final points are assigned as one measure. This means that SSI colo and SSI hyst are combined to be one SSI measure, and the measure is designed to be weighted. This means that if your facility performs one of the surgeries more often than the other, then the surgery performed more often will have more impact on the final SSI measure. Here is the formula for calculating the SSI measure. Simply multiply the total points for each type of surgery by the predicted number of infections. Then you divide by the total number of predicted infections for the surgery types. This creates a weighted SSI score. The HAI measures are combined with the RCSI measure to form the safety domain, which accounts for 20% of the hospital value-based purchasing total performance score. Although your final results will not be known until the end of the year, you can track your data to see how your facility is currently doing on the HAI measures for value-based purchasing. You need to be aware that for both CLABSI and CAUTI are still based on ICU locations only. You can also pull your 2013 baseline data from NHSN, but do be aware that if you made any changes after the submission deadlines, then it will not be the same as what CMS is using for fiscal year 2017. I would recommend that if you would like to get your official baseline numbers, you should run the Hospital Value-Based Purchasing Baseline Measures Report for fiscal year 17 in the QualityNet secure portal. Before we move on to the Q&A portion of our presentation, we'd like to ask a couple more polling questions. For this question, we would like to know which state are you from? Can we open the polling question for this? Have those results. Excellent, thank you. Move on to our next polling question. The next question we have for you is how many people are watching the presentation on your computer or login information? Thank you for answering the following questions. Before we get into the Q&A, I just want to take a moment to thank Robin Neal, the Director of Infection Prevention at the Care New England System. A while back, Robin and I co-presented on NHSN data analysis, and she helped develop many of the slides that were used in this presentation today. Thank you, Robin. And these right here are just some useful resources if you're interested in learning more about the SERV, data analysis, or the risk model. I'll now hand it over to Maureen, and I encourage you to ask any questions that you may have.
Okay, thank you, Blake and Alyssa. It was a wonderful presentation. At this time, we will take a few questions. We have about 6 minutes left till the end of the hour. If you would like to ask a question, simply press *6 on your phone to unmute your line, and we will take questions. I have nothing in the queue right now that's been written in, other than if you need presentations, you can go to the link that was sent to you, and the presentation should be in that link. Any questions?
Yes, I have a question related to baseline data, the national baseline data for CAUTIs and CLABSIs. Where would I find that information?
I usually
the annual report should have that in there. You get an annual HHS report, or do you have it somewhere else, Blake?
Let me just ask, are you referring to value-based purchasing, or are you referring to deriving expected infections?
Not value-based purchasing.
Okay. Yes, the NHSN does publish annual reports, and so if you do a search on the NHSN report, you'll find it on their site. They have a whole page that has reports that go back for several years.
Okay, thank you very much.
Hi, Blake, this is Robin. Hello?
Yes, go ahead.
Oh, thank you. Thank you for the presentation. It's very good, all of you. I have a statistical question. Some of our sites prefer to track rates in addition to SIRS. And one of the things I struggle with is seeing the rate bounce around from month to month. Is it a statistically valid thing to use a control chart to watch what rates do over time, like you would for a process measure? So could you use standard deviations and watch for points on one side of the line and that kind of thing as you would for any kind of a process measure? Can you do that with an infection rate?
I don't see why not. I think it would be a good idea to do that.
Good, thank you.
Hey, I have a question. Is there a report available where we could determine whether or not our SIR for CLABSI, let's say, for example, at one of our hospitals, was statistically significantly different than the national SIR for CLABSI?
Is there a particular report for that?
Yeah, my understanding is that in the most recent CDC report that came out in March of 2015, there was a statement in there that said 9% of hospitals had an SIR that was statistically significantly worse than the national SIR. And I'm wondering, how do we find out if our hospital is one of those 9%? Is there a report where that would be published?
Right. So comparing it to more recent data, is that?
The 2013 data.
Right. The first thing that comes to mind is possibly using the calculator in NHSN, which you could put that data in for the national data and then put in your hospital data and have it compared, and it'll calculate that data, the p-values for you.
Well, okay. Great. All right, we'll do that. Thanks.
Sure.
Any more questions? Okay, since we're getting very close to the end of this hour, I would like to thank you all for a great discussion. I just have a few last announcements before we end today's webinar. One When you close your webinar today, you will be directed directly to a very brief evaluation, and we encourage you to fill this out. If you don't have time today or are sharing the computer with someone else, you will receive a follow-up email with a link to the evaluation tomorrow. We ask that you please complete it. Your feedback is very important, and it helps us to provide you with meaningful presentations. So please take those 5 or 6 extra minutes to complete the evaluation. In the invitation for our next webinar, which will be June 30th. We will include a link to our website where you will be able to find the presentation, the recording, and the transcript of today's webinar. Or you can keep checking the website for updates. Now, the June 30th webinar will be one of those webinars that we're going to ask that you do please make every effort to attend, because it's one of those CMS mandatory ones, because we will be talking about VAE, ventilator-associated events. And we have Dr. Mark Murtowski from UConn Medical, who will be doing the presentation. Again, thank you so much for attending today. Have a great day. Bye-bye, all.
Excellent presentation. Thank you.